To solve the problem of dealing with a lot of names that map to a lot of numbers, we're going to use our second strategy for managing complexity. Not the layering strategy, like application and transport and network layer, but the hierarchy that is distributing the responsibility for resolving and managing names. And we can do that because there is some structure to a name that we use to refer to something on the internet. This overall name, www.cs.utah.edu, that's called a domain name, and it has these dot-separated parts that are important. It doesn't, as we said before, mean that each of these four pieces maps to an individual number, but the structure is useful in that this part at the end is a largest classification. That's called the top-level domain, edu, and other top-level domains include com and org, and country codes like US and CA and CN. And that piece tells us how to get started, and we work our way to more specific pieces. It tells us how to get started because everybody in the world agrees on some root server that knows about these top-level domains. It's not literally one server, it's replicated several times, but in any case, it's servers that everyone has to agree on who to ask to start answering questions. When we make a request to the root server about edu, then it will tell us who to contact to ask specific questions about edu, or specific questions about com, or specific questions about CA, and so on. And then we tell the edu server we're looking for www.cs.utah.edu, and it says, well, I don't know all the answers, but I know who to ask for Utah. So it'll tell us the Utah server, or if it was byu.edu, it would send us to the BYU server, and so on, working our way down. Again, each of these layers can have replications. There doesn't have to be just one edu server, but the root server can tell us a suitable edu server, and this edu server can tell us a suitable Utah server, and so on. So to break that out, if my laptop wants to connect to www.utah.edu, it'll send a request to some local server, and if the local server doesn't already know the answer, it sees the .edu at the end, and it contacts the root server and says, tell me who to ask edu questions of. And the root server gives back some number. That number corresponds to a server that the root server knows can tell us more about edu addresses. And then the local server will say, okay, I will ask that edu server about utah.edu. And the server says, well, I don't know all the answers, but here's who you contact to get utah.edu answers. And then the local server sends www.utah.edu to the Utah edu server, and then probably it says, here's the number you're looking for. The local server gets that number and forwards it back to our client computer. It probably also remembers the answer in case someone else asks it this question again. Notice that in this case, our client is asking a full address and just wants the final answer. And so in its request, it sets a recursion desired flag. Whereas the local server, as it works out the answers, it needs to contact a bunch of other servers. It's using the same protocol, but in these messages, it does not set recursion desired. It just says, tell me the next step. And the local server will remember the result and remember all the steps that it took previously. So it's going to cache those answers. And if we ask it for the same address again, after some short timeout, then it will give us the answer without having to contact anyone. So these answers that you get back in DNS, they have an expiration date on them, usually on the order of minutes or hours or even days sometimes. And so the local server does not need to ask again if it's gotten an answer recently enough. If I ask about umail.utah.edu and no one has asked that, that means the server doesn't know the umail part, but it does know the utah.edu part because I asked recently enough about www.utah.edu. And so it goes back to the Utah server to get an answer specific to umail. It will remember that answer and give that back to the original client laptop. There's nothing special about the fact that this is a laptop and this is a server. Some laptop could ask another laptop using DNS to answer questions. Most likely that other laptop, though, would have to contact some other servers, or it could contact the root servers and other servers if it wanted to somehow. And in fact, you will do this yourself as a homework assignment. Build a DNS server that can run on a laptop that would answer questions from other processes on your laptop or from other laptops.